Okay, let's do practice problem number 8 on page 188. It's kind of a complicated problem, so let's go through it step by step. Let's read it from the book, and I'll zoom in a little bit here. But it says the sun is considered to be a satellite of our galaxy, the Milky Way. The sun revolves around the center of the galaxy with a radius of 2.2 times 10 to the 20. Whew, that's a lot. Meters. The period of one revolution is 2.5 times 10 to the 8 years. That's 250 million years. We make one trip all the way around the galaxy every 250,000 years. Okay. Find the mass of the galaxy. Assuming that the average star in the galaxy has the same mass as the sun, find the number of stars. Find the speed with which the sun moves around the center of the galaxy. I might do part C before I do part A, actually, because that's the way I like to do these things. So let's get started. So we have, here's what's given. So we have this spiral galaxy. And it's got spiral arms like this, and some beautiful pictures online of what our galaxy looks like, because they've kind of figured it out. And we're about, we'd be about right in here, maybe. And let me zoom out a little bit. And so we're going in a circle around the galaxy. And the period, they said, was 2.50 times 10 to the 8 years, right? Yikes. And the radius of our orbit is 2.2 times 10 to the 20 meters. That's a long ways, okay? It's about 30,000 light years. So the light from the center of our galaxy, which you can't see this time of year, but in the summer you can look towards Sagittarius and as a constellation Sagittarius, and you're looking towards the center of our galaxy, and the light from the bulge of the center of our galaxy takes about 30,000 light years to get to us. So we're looking at what those stars look like a long time ago. Our whole galaxy is about 100,000 light years across. All right, so we know that, and we also know the mass of the sun. I'll put m sub s is, what was it, 1.99 times 10 to the 31, I think? Is that right? 10 to the 31 kilograms? Oh, now you're going to make me look it up. I think on page 1, where is it? On page 178, there is a 1.99 times, times 10 to the 30. 1.99 times 10 to the 30, not 31. You have to know that, right? Because you want to know how many suns in the whole galaxy. All right, so what are we trying to find? I'll put the find over here. Ooh, I better hurry. We want to find the mass of the galaxy. M sub capital G, mass of the galaxy. B, how many stars? And then C, the period. Now, as you're going to see, I'm going to do the period first, or not the period, I'm sorry, the speed. We already know the period. We want the speed of the sun. So, let me zoom in further. So let's solve. Now, we know this, that the force of gravity between the sun and the center is equal to G times the mass of the sun times the mass of the galaxy. So we're going to assume that all this mass is like it's concentrated right there in the center, over r squared. Now this is what we're trying to find. and all that. Now, this is going to be equal to a centripetal force because the sun is moving in a circle. So this is going to be the mass of the sun times the velocity squared over r. And so I'm going to say, okay, let's solve for the mass of the galaxy here. This cancels this cancels this, and so the mass of the galaxy is going to be equal to v squared times r divided by big G, right? So yep, and yeah, that's right. So so I know this and I know this. Now I need the velocity. Now this is where I do things differently than what the book does, and I'm sorry, but this way's better. V equals 2 pi r over the period. Now we already know what r is in meters, but we have the period in millions of years, or actually in years, so we have to change that. So let's do that. The period equals 2.50 times 10 to the 8 years. And let's see, that's 365.25 days. Why the 0.25? Because of a leap year, on average, right? We have a leap year coming up next month, actually. It's leap day. It's coming up. Days in 1 year. There's 24 hours. Whoops, 24 hours in 1 day. And in 1 hour, there's 3,600 seconds. So the period, when I get my calculator out and do all this, I'll try to go fast here, 2.5 times 10 to the 8 times 365.25 times 24 times 3,600 equals, and I get 7.89 times 10 to the 15 seconds. So that's 1/4 of a billion years is this many seconds. Okay, it's a lot. So now I can figure out what V is, which is actually my answer to part C. It's 2 pi times r, which is 2.2 times 10 to the 20 meters, divided by 7.89 times 10 to the 15 seconds. And I get 1.75 times 10 to the, let's see, 1, 2, 3, 4, 5, times 10 to the 5 meters per second. It's a long ways in 1 second. It's really, really fast. Was that the answer that they gave you? Does that match with what you guys got? Okay. So that's actually the answer to part C. But now I can figure out the mass of the galaxy, because it's this speed squared times the radius divided by G. Okay, and when you do all that math, you get a big number. And you get 1.01 times 10 to the 41 kilograms. Now, I'm almost out of time. Take that, divide it by the mass of the sun. So I'm going to divide that by 1.99 times 10 to the 30. And I get 51 billion stars. But that is not accurate. Oh, I'm sorry, I'm off screen. If I'm off screen, let me know, okay? That's not accurate. Because guess what? A second. Our sun is way bigger than the average star in the galaxy. So the actual number of stars is hundreds of billions of stars. That is all.